In this lab, scientists have one hope: to help people who never thought they'd be able to have a family to do so. Infertility affects 1 in 6 people worldwide. The go-to route for many couples struggling to conceive is in vitro fertilization, or IVF, where egg and sperm are usually combined manually to try to create an embryo. Scientists here at Columbia University Fertility Center are automating parts of that process, though.
What we're doing here at Columbia is developing technologies that could really advance reproductive medicine to give that extra few % chance to every single patient that they could go on to have a successful pregnancy.
Those few % really are the difference between conceiving or not. And considering average sperm count worldwide has halved since the 1970s, it's perhaps little surprise that insufficient sperm can be a substantial cause of infertility. The STAR system aims to address the problem by searching for sperm in semen samples from patients who are thought to have none.
You can do extended search, meaning spending 8-10 hours looking one drop at a time. What this system is doing is automating the whole thing.
It takes over 8 million images an hour using AI to scan the samples. It can pinpoint a single sperm which may have gone undetected in a previous search.
It just takes 1 to 2 hours to go through the whole sample, scans it, and the AI finds if there's a sperm or not.
What are we looking at here on the screen now?
So we're looking at the sample passing through the microfluidic channel. Most of it is debris. If it finds a sperm, it sorts it for the IVF process. And once the run is completed, we take all the sorted sperms on the droplet and hand it over to the embryology lab.
There you're seeing a difference between essentially a 0% chance of having a child to, well over 70, 80, 90% chance. To take a patient who's told, I'm sorry, you'll never be able to have a biologic child, to be able to give them that possibility is tremendous.
Once that precious sperm is captured, it's united with an egg to create an embryo. And that happens here, where eggs are brought after being surgically removed from a prospective mother.
Once the eggs are prepared for fertilization, then they're brought to a very specialized micromanipulation station. In the case of men who have these exceedingly low sperm counts, like the men who have the STAR procedure done, even if there's only 1 or 2 sperm, instead of the usual hundreds of millions of sperm, you can still take that 1 sperm and place it directly into the egg.
That's all it takes.
That's all it takes.
Next, the embryos are placed in the best environment possible to grow successfully. Enter the ART pipetting robot for the IVF laboratory, April for short.
The embryos grow on these specialized plastic dishes, and rather than making that environment by hand, where there is a natural variability, we're using robots which allow us to prepare the plates to be absolutely ideal.
As well as making the IVF process more efficient, it's also hoped that these technologies can bring down the cost, which can run into tens of thousands.
I think what's even much more important than that is by increasing success rates, it's easier for a patient to have that child. So I think there's a great reason to be optimistic and hopeful for our field.